Hello friends, today I will discuss the methods of determining the depreciation. Under this topic, I consider what is the necessity of this depreciation and the methods of calculating the depreciation for electrical equipment, the straight line method, diminishing method, sinking fund method, and later the numerical problems will be solved. To understand this properly, let me take a two-wheeler and its depreciation. If the age of the two-wheeler is between 6 months and 1 year, then the depreciation applied on the principal amount or initial value is 15%. If the age of the motorcycle is between 1 year and 2 years, then the depreciation applied on the initial value is 20%. Similarly, if the age of the motorcycle is between 2 years and 3 years, the depreciation applied will be 30%. If the age of the motorcycle is between 3 years and 4 years, the depreciation that is applied will be 40%. After the useful life of the motorcycle, whatever depreciation value is obtained, that value will be subtracted from the initial value of the motorcycle, and the value obtained is called the motorcycle value after the end of the lifetime. Let us take a new problem here to understand the depreciation. So let the initial cost of the motorcycle is 1 lakh. Let the useful lifetime of the motorcycle is 4 years. Then depreciation at the end of 4 years as per this law, that is 3 to 4 years means 40%. So 40% into 1 lakh, that is 40,000. Then two-wheeler value at the end of lifetime means after 4 years is nothing but initial value minus depreciation value. The depreciation value after 4 years is 40,000. So once the initial value minus the depreciation value is done, then the value that is obtained is nothing but the two-wheeler value at the end of the lifetime, that is in this case it is 60,000. But this depreciation value, that is 40,000, is not sufficient to replace the equipment, because the value of the two-wheeler is only 60,000, whereas depreciation value that is obtained is 40,000. Next, having understood this, which is commonly used in the market, now let us move to the method which is used in the case of electrical equipment, straight line method. So in this case, every year the value of equipment and other property in the plant reduces due to the depreciation. So every year depreciation charges are kept aside by the time useful lifespan of equipment reaches the depreciation amount. So in this method, if the graph is drawn between asset value and the useful lifetime of the equipment, the graph will become like this. It is a straight line, and here P is the initial value of the equipment, and this is the useful lifetime of the equipment up to here. So whatever value is obtained here is called the asset value or scrap value. The difference between this purchasing price and the scrap value is called the total depreciation, and the scrap value is mentioned with letter S. From this, we can calculate the annual depreciation charge, that is equal to total depreciation divided by the useful lifetime of the equipment. Here the total depreciation means from here to here, that is P minus S is nothing but total depreciation, and the lifetime, if it is assumed as n years, so then substitute here n. So here P is initial cost of the equipment and S is the scrap value after useful life of the plant. What are the drawbacks in this method? It does not take the interest drawn on accumulated amount every year, and constant annual depreciation is not correct. So let us take a problem on this straight line method. Let the initial value of the equipment is 15,500 and let the scrap value of the equipment is 10,000 and let the useful life of the equipment is 15 years, that is small n. Then the annual depreciation charge for this useful time of 15 years can be calculated like this. So the total depreciation is given by initial value minus scrap value. Initial value given as 15,500 and whereas the scrap value is 10,000 and divided by useful lifetime of the equipment is 15 years. Once it is simplified, the value we get is 3,000. This means every year 3,000 rupees should be kept aside for 15 years. Next method, diminishing value method. So in this method, depreciation charge is made every year at a fixed rate on the diminished value of the equipment. That is, depreciation charge is first applied to the initial cost of the equipment and then to its diminished value. So to understand this method, let me take first numerical, then we go to the mathematical analysis for this diminishing value method for depreciation calculation. So initial cost of the equipment is 10,000, annual rate of depreciation is 10%. Then the depreciation charge for the first year is nothing but 10% of this 10,000, that is 1,000 rupees. Then the value of the equipment after 1 year, that is initial value minus the depreciation charge kept aside at the end of the first year is 1,000. So then the value of the equipment will become 9,000, that is P minus S. Next, depreciation charge in the second year. So this is the new value of the equipment after 1 year, that is now 9,000 instead of 10,000. Now the depreciation charge should be applied to this amount, that is 10% of 9,000, that is 900. Then the value of the equipment after second year is nothing but the value of the equipment at the beginning of the second year, that is 9,000, and the depreciation value at the end of the second year is 900. So 9,000 minus 900 is nothing but 8,100. Similarly, depreciation charge in the third year is nothing but the value of the equipment after second year into the rate of depreciation charge, that is 10%, that is nothing but 810 rupees. Then next, the value of the equipment after third year. This is depreciation in the third year, whereas this is the equipment value after third year. So before the third year, the value of the equipment is 8,100, and the depreciation charge is calculated in the third year is 810. So 8,100 minus 810 rupees is nothing but 7,290 rupees. In this method, depreciation charge goes on, reduces year by year, and reaches the minimum value by the time it reaches its useful lifetime. Now let us take the mathematical analysis for this diminishing method. Let the P is nothing but capital cost of the equipment, and S is the scrap value after useful lifetime of the equipment, and X is the annual depreciation rate. Then the value of the equipment after 1 year is nothing but P minus into XP. So that is P minus X into P. So P is common, so P into 1 minus X. Then the value of the equipment after 2 years is nothing but diminished value minus annual depreciation. So diminished value is this, that is the value of the equipment, that is P minus XP minus P minus XP into X, that is the annual depreciation after 2 years. So that is, after simplification, we get here P minus Px minus Px plus Px square. After taking these two together and rewriting this equation, we get Px square minus 2Px plus P. Then common term is P, that is x square minus 2x plus 1. This can be written as like a minus b whole square form, that is P into x minus whole square, x minus 1 whole square. Then the value of the equipment after n useful years, this is for 2 years, for n years it will be P into 1 minus x whole power n. Then the value of the equipment after 2 years, after n years or useful lifetime, is equal to the scrap value S. That is, S is equal to P into 1 minus x whole power n. So now it can be written scrap value is nothing but is equal to P into 1 minus x whole power n. That is value of the equipment. So rewriting this equation, 1 minus x whole power n is equal to S by P, and from that you can calculate 1 minus x is nothing but S by P whole power 1 by n. Then from this, the depreciation factor, depreciation value after n years is nothing but 1 minus S by P whole power 1 by n. So in this diminished value method, calculation of the depreciation rate is the main problem. So once it is known, that is X is known, then annual depreciation to be made for the first year is nothing but X into P. So that is, X is known, that is 1 minus S by P whole power 1 by n into P. Similarly, annual depreciation charge for the subsequent years can be calculated. So the initial value P of the equipment reduces through depreciation to the scrap value S over the useful life of the equipment. This depreciation charge is independent of the rate of interest which it may draw during accumulation, and the interest drawn is treated as income on the accumulated amount. When the graph is drawn between the asset value and the useful life of the equipment, it will be obtained like this. This is the initial value of the equipment, and this is the end of the useful life, and whatever value is available or such value is available, that is nothing but scrap value, and the difference between the initial value and scrap value is nothing but total depreciation.